Hello, everyone. So this is ASCollectionNode, a fireside chat, and I just wanted to, this is going to be a sort of technical presentation, so if it's boring, then bear with me. You code all day, so I'm sure you can deal with a little bit of code here and there. So in order to, the goal of this talk is to promote an understanding of how Uicollectionview and ASCollectionNode do their work, how they each perform processing inside, how to use them correctly, and why ASCollectionNode works the way it works. And so hopefully at the end of this, we'll have a huge Q&A section. So if you have any questions about really anything related, then feel free to ask them. So the talk is going to start with an exploration of how Uicollectionview outside of AsyncDisplayKit loads its data. And hopefully that'll be sort of interesting. This stuff isn't super well documented by Apple, so it took a little bit of learning to see how it's all done. All right, so this is the beginning of a sequence diagram for Uicollectionview loading content. So this could be after you've inserted 1,000 items into your collection view. It could be during the first layout pass when CollectionView loads the initial data from the data source and loads the initial batch of cells. And so we start off with these four actors: the CollectionView, the data source, which is in our case the section controller, the CollectionView layout, which in our case is usually masonry layout or something, and the delegate, which is also the section controller. And we start off on the main thread, let's say having inserted 100 items. So the collection view is going to ask the data source for the number of sections, and then for each section, it's going to ask the data source for the number of items in that section. This is pretty straightforward. Once it has the item counts for each section, it performs a validation step. A lot of people know the validation step for a collection view. If the number of items that are now present in each section doesn't match the old saved values, plus or minus the changes that have been made in the meantime, then the collection view throws an exception, because otherwise its internal array modifications, deletions, moves may cause a crash then. So the notion here is just crash early and figure out what happened. If the update, if the new data is valid, then we continue on, and the collection view tells the layout to prepare its layout. And this is a pretty lengthy process where the collection view layout is going to go through each index path and reach out to the delegate to get the size of that cell. So, you know, in the pin case, we need to find the size for each pin so that the collection view layout can assign frames to each cell. In the UI collection view case, the way this is usually done is you have a mannequin cell, which is like a singleton cell instance, and you configure that cell as if it were being loaded for this pin. So you do set attributed string, set image URL, set all these things on the cell, and you basically set up the cell as if you were going to draw it. And then you ask UIKit to give you the size of the resulting cell and return that. And so you go through each item and you do this. You can see this long block here on the left is the big, this is the call to, This is the call to essentially reload data that's all running during this time. And so you go through each item, the layout goes through each item and performs this dummy cell configuration and gets the size. Unfortunately, after each dummy cell configuration, the resulting value is essentially thrown away. The size is saved and returned to the layout, but the resulting layout and the resulting configuration of that dummy cell is just overwritten by the next item and the next item. So you do this for 20 or 30 items. Once the layout has all the sizes, it does a little bit more internal math to decide where things should go. And once it's finished, it returns from prepare layout. You can see below. Once the layout is finished with prepare layout, the collection view asks the layout for what elements are visible on screen. So it calls layout attributes for elements in rect with the visible bounds. So hopefully the layout can quickly check the frames that it has and return, okay, well, items 0, 1, 2, 3, and 4 are visible on screen. And the final step is the collection view for each visible item is going to call out to the data source to get a configured cell ready to display that particular item. And you're basically going to do the same thing that was done during the sizing step again. You're going to take the cell, set the attributed strings, set the image URLs, configure it, and then the collection view adds the cell into itself using add subview. And then during the future layout pass, which is probably going to happen basically now because this is in a layout pass, but the subviews of the cell are going to get laid out. So if the cell has image views and labels and all that stuff, then they'll be laid out. So at that point, the collection view is done and it's ready to return. So that is essentially how collection view loads data. Are there any questions about that process?
So that's for the UIKit version without AsyncDisplayKit.
Exactly.
And I guess the key note is that all of this operation occurs in one huge blob all at one time.
Exactly. This big bar on the left is one method call on the main thread. And so if this takes more than 16 milliseconds, then you've guaranteed to drop a frame. But in practice, since there's other things that need to happen for a frame to be drawn, you really have much less than 16 milliseconds to get all this work done. Any other questions?
Can you shrink it down so we can see it all at once?
I will shrink it down some. I think the resolution's pretty low on the feed, so it may be hard to see it all at once, sorry. But what's up?
So this is the case where you're reloading from scratch, and this is awesome. I've actually never thought about this in this detail. It's really cool to see. As you change the viewports, as you scroll, does it rerun segments of this, or how exactly does that work?
So what'll happen is as you scroll, this last loop down here is going to be performed for every frame. So it'll just do this again. And that can actually add up. It can add up because that last call to cell, if you're using auto layout, that can have exponential costs. And so you can end up doing a pretty significant chunk of work. What's up?
Where is the content size for the collection?
That's a good question. I omitted that because it's, he asked where does the collection view set the content size for itself during this process. And I omitted that because I wanted to hopefully make this a little more legible, but that is set just here, just before layout attributes for elements and rect and just after prepare layout. The collection view will call out to the layout and it will ask for the content size. Because presumably, even though the collection view does not want to know the frames of all the items, it's specific that the collection view is architected in a way that it doesn't need to know the frames of all the items. It does need to know the overall content size, so it'll ask at that point. Okay, cool. So that is how UicollectionView updates work, and yeah, it is during reload data, and if a collection view has not been loaded yet, then it will call reload data on itself during the first UIKit layout pass. So that's when this will happen. And that's that. Okay, now let's go to ASCollectionView and how it works internally, and hopefully we can learn some stuff about that. So a very similar basis. We're on the main thread, and I omitted the number of items in section and section count, but they're called as well. And then ASCollectionView does the same validation step that UicollectionView does, and ensures that the data source counts match the old ones plus or minus the changes. If the update is valid, then the ASCollectionView calls out to the data source for each item to get a node block for the item at that index path. And it's important that this is done immediately during the loading process, because as soon as this method returns, the data source could presumably change again and again and again. So we need to get all the node blocks for all the items in the collection view right now. And once we have all the node blocks, the actors here are the ASCollectionView, the data source, this internal component that we have called the data controller, which works on a background queue rather than on the main queue, and a node, which we'll see comes in later. So the ASCollectionView validates the update, gets the node blocks for each item, and this method, node block for item index path, is pretty fast because all the data source needs to do is usually get an object out of a collection and return a block. So not a whole lot of work is being done in here, and that's pretty critical. And you can see that this bar on the left, which corresponds to the same bar from the previous call, is a lot shorter. And so the chance that you're going to drop a frame or miss a user touch during this time is much, much lower. But you also notice that by the time the block is done, we haven't inserted the cells yet. So we're not drawing any cells yet, but we're ready to start processing. So the collection view calls out to the data controller and hands the node blocks over to it, says start measuring these and call me back when all these node blocks have been run, the nodes are configured, the nodes are laid out, and they've saved their layout inside themselves and they're ready to rock. So does that part make sense to everybody? Okay, cool. And so a little bit later on a background thread, really a background queue, but whatever, the data controller starts this measure nodes process. And so for each node block, actually concurrently in parallel, the data controller runs the node block, which calls alloc init on the node, alloc init the whole subtree of nodes. They configure themselves in the same way, set attributed string, set image URL, set this, set that. And then once the node is created and configured, the data controller lays out the node, which is a step to tell the node, figure out your layout and save it for the future. And so, as I said, this is done in parallel, which is really important. So you've got some tri-core devices like the iPad Air 3. Really, any device other than iPhone 4 has more than one core. So doing this same configuration and layout logic in parallel while the user is still able to interact with the app and animations are able to continue is pretty important. So after that's been done for all the node blocks, and we've transformed the node blocks into measured nodes, now back on the main thread, the data controller calls out to ASCollectionView and hands the array of measured nodes back. And the ASCollectionView calls insert items at index paths into the Uicollectionview, and the same process we just saw begins. But that process is much faster because size for item at index path is just a matter of returning node.size, which is already computed. And cell for item at index path is just a matter of adding the node as a subview of the cell. And the node has already laid out its subviews and everything is already configured. So those two methods are much, much faster now. And so when this data insertion into the Uicollectionview happens, it can return much faster. Any questions about this process? What's up?
So if you have like, I don't know, thousands of nodes being initialized and all of them having, their own respective data, can you just get a lot of memory pressure from having all these be created in parallel? And do you guys do anything to handle that?
It is possible. The memory pressure doesn't become a problem until you have many, many, many nodes, like 10,000 or 20,000, because nodes are pretty lightweight objects. They don't have views, they don't have layers by default. They don't store any images, where images are usually where your memory gets consumed. So nodes are pretty lightweight, but the one thing that does become a problem, and we're working on solutions for this, is it can take time. It can take a lot of time to allocate and measure all those nodes. And so for cases like a photo grid, where all the nodes are the same size, and you usually got a whole bunch of them, we have an API for performing batch fetching as the user scrolls down, where you can sort of look ahead and add more content below and have that running asynchronously in advance. But trying to insert all that data right at the outset is not something we have a great solution for. So yeah, I have some notes here. Oh yeah, and then when the cell comes on screen during scrolling and that last little block of the UicollectionView work is done, for each visible cell, call cell for item at index path, layout subviews on the cell, that's also pretty fast. So after the insertion is done, as the user's scrolling, they're way less likely to see any interruptions because the cell is practically already configured. Okay, so, oh yeah, any other questions about the data controller doing this note? What's up?
So this is like the insertion case. What about deletion and like updates? similar, or does deletion just happen concurrent or on the main thread immediately because it's cheaper, or how does that work?
Right now, deletion doesn't happen immediately. It still goes to the data controller because the data controller has an internal array that needs to be updated. But deletion will typically happen very fast because all it has to do is tell the data controller, okay, on your queue, delete these objects and call me back when they're deleted, which takes very little time, but it is still asynchronous. Yeah. So what's up?
And the calls to insert items that index has, are those chunked in any way so that we don't like block the main thread for a long period of time? If we call like, if we don't do
Yes,
inserts at once.
you're absolutely right. I didn't express it in the slide, but you're absolutely right. Those, after batches of nodes are inserted, we call back to the collection view to insert those objects in chunks. But the whole update isn't completed until all those are done, obviously. What's up?
Silly question. What's the priority of the background thread? Because although it's not done like in the main thread, but the main thread is waiting for the results of this calculation going in the background thread, right?
Mm-hmm.
So what's the priority of the background thread?
Okay, he asked what's the priority of the data controller's background thread in this process. The priority is dispatch queue priority default. We really hesitate to use any priority other than default because of potential priority inversion problems. And so that's the priority.
As far as the main thread waiting, main thread doesn't actually wait unless you call, wait until all updates are completed. And if that occurs, then we wait on the queue, which affects the priority internally. So in other words, this thread scheduler will promote the background thread to run at a higher priority. If it knows that a high priority, it donates the priority of the main thread to a background thread, but only in the case that you perform that blocking call.
Okay.
And for that blocking call, it has to measure the sizes of all the nodes.
Yes, so it does, in the normal case, it batches them in, I think it's groups of 10 right now. So if you did have 1,000 nodes, you'd still start seeing them before they're finished. But if you perform that blocking call, it does wait for all of them. And so the key question of whether that is okay is the size of the data source, basically.
All right, cool. So I hope that was illuminating to see how those two processes work. I'm sure there's some way to go to the next slide here. Okay, so this is just a quick summary, like a side-by-side summary of the UIKit and ASDK approach and some of the pros and cons of each one. So the first one is that in UIKit, you have 2 layout passes per item. Technically, you have an unlimited number of layout passes per item because every time the item comes on screen, a new layout pass is going to run. But in the base case, you have 2, which is obviously a nice thing. In UIKit, the main thread immediately catches up to the data source as soon as the data source is updated. And so this is good because it's very easy to program for, but it's bad because you can miss touches if the user touches during that catching up process, and you can drop frames during scrolling or animation. And in ASCK, the data source is allowed to get ahead of the view layer by default. I'll talk a little bit about our wait until updates are committed method in a minute, but by default, the data source is allowed to go as far ahead as it can. And that means that we get nice, smooth animations and scrolling and reliable touch response. But it does mean that if the data source has updated since the view layer has caught up to it, then the index paths that the view layer sends out to it won't necessarily correspond to the same objects anymore. And I'll talk a little bit about my advice for trying to mitigate that hassle. In UIKit, by default, there's no object to represent the items in your collection views. So, if you have 1,000 objects, then UIKit doesn't provide you a ready-made object to represent each cell or each potential cell, each item. A lot of common frameworks like Nimbus Kit provide something like this, which is like, NI table view model, table view row item type thing. And in AsyncDisplayKit, we do give you an object to represent each item, which can be a convenient place to store model object references or state, whatever you need. At the outset, it seems very, just a quick note about this from experience. At the outset, it seems very promising to use model objects themselves to represent the rows in your table view or something. But this turns out not to be a great idea because there are many cases, especially in modern apps, where you're going to have a row or you're going to have an item that doesn't correspond to a model object. For example, maybe you insert an ad or insert a banner at this index, or maybe there's a see more button at the bottom or something like that. And as soon as you have one of those, now you're translating index paths between your data source and the collection view, or you have like some like null model that you're using to represent the row. So it can be really, really important. I really advocate for, no matter what you're doing in iOS, to have some object that specifically represents this is a row, and the row can have a model object or it cannot. Just a quick note there. In UIKit land, as soon as an item becomes 1 pixel visible, all the layout and drawing are done immediately, and the main thread is blocked while that happens. And that's not great, although it does guarantee that we don't need to have any memory in advance dedicated to this item. And it also means that the item will always be totally rendered when it comes on screen because it wasn't allowed to come on screen until it finished rendering. In AsyncDisplayKit land, we look ahead and we do, we lay out before the items are even inserted, and we look ahead and do rendering based on the interface, the range controller and the tuning parameters that I think you guys are probably somewhat familiar with, so that under normal conditions, non-trivial or non-pathological cases, you're going to have the contents rendered before the item becomes visible during scrolling, but you're not going to have to block and wait for it to happen. As a note, if you want to replicate the UIKit behavior of waiting and basically stalling until the content's rendered, we have a flag called never show placeholders that you can set on your cell node. And if the cell node is about to come on screen and it hasn't finished, the render ahead process hasn't finished, then we'll wait. So you can mimic the UIKit behavior there. And another quick aside, the fundamental thing, the absolutely fundamental thing that AsyncDisplayKit does is we allow for drawing to occur on multiple threads. We allow for concurrent drawing. So UI label, UI image view, UIKit classes, all their drawing is always done on the main thread. And what we fundamentally have aimed to do is to allow that drawing to be done in the background in parallel. And so even if you have to wait for this rendering to finish, even if you want to wait so that the user never sees the placeholder, it's still better to wait on 3 cores doing this drawing than it is to wait on 1 core drawing each of the components in serial. Any thoughts or questions about this? What's up, Alice?
So regarding the second con in ASCK land, so it seems that there's a lot of ways for you to potentially bypass that issue. Help.
Maybe the people.
Hello. What best practices in terms of
The best practice is, I recommend building things in terms of objects, in terms of, so if you have a list of boards and the user is allowed to select a board, having a selected index path field on your controller, have a selected board field, selected board field, or of the node that represents that board. You can, for example, let's say the user, we download some more boards, and we insert a board at index 0, your selected index path will now point to a different board than it used to point to, and you may not know. It's very natural to just user selected a board. The board is about to store. And otherwise, if you want for the is sort of strangely named, but what it means is wait for the view layer. After you call that, you can be guaranteed that the collection view data, index paths, and items match the data sources, index paths, and items exactly.
The data source. You set up nodes for view. Or sorry, the cells. So for the wait call, go all the way at UIKit level.
The wait call goes all the way to kit level. So Uicollectionview and ASCollectionView, ASCollectionNode is ASCollectionView. They all be in sync across the board. So the next slide is this wait method, which, okay. So it blocks the main thread and transfers control basically to the main thread in order to let it do this processing and submit the update up to the Uicollectionview so that everybody's in sync. And this can be really useful if you've made an edit, you've just submitted, insert 20 items into the collection view, and your designer says, I don't want the user to see another frame drawn until those 20 items are on screen. So if you want to ensure that all the items are ready to be drawn during the next frame, this method's useful there. The method's also useful if you inserted 5 items into the collection view and you want to get the node that resulted from that. So you inserted 5 items, you want to get the node for item at index 0 now. This method is useful there. There is some overhead, obviously. It can interrupt the UI because basically the big, in short, the big long line at the left on the first sequence diagram for Uicollectionview, that whole process is now, it's quicker because of the way that nodes are built, but you're essentially going to wait for all that to happen right now. It's important that you don't call this method during the willDisplayNode or didn't-in-displaying-node callbacks because those callbacks are sent out of Uicollectionview in the middle of processing updates. So if you're in the middle of updates, it's not safe to wait for updates to finish. Does that make sense? It's kind of wacky, but that's just the way the cookie crumbles. And finally, I've heard a lot of chatter about reload data immediately. I think it's everybody's favorite method, and I understand why. It is exactly the same as calling reload data and then calling wait until all updates are committed. In fact, in the implementation, it's practically implemented in those terms.
Isn't that one more expensive than like just doing it if you have a Uicollectionview reload data?
Yeah, so the reload data method, any of its variants, we have reload data immediately, reload data with completion. Any of those variants are going to be more expensive in general than the Uicollectionview version because you're telling AsyncDisplayKit to throw away all of the nodes and all of the work that it has done in advance and to regenerate them from scratch. Whereas since Uicollectionview hasn't done any work in advance, you're not really throwing away that much. Uicollectionview will still have to perform that sizing pass with the dummy cell for every item in the collection, and it's still going to have to configure and lay out the visible cells again, and the layout will have to assign frames to each item again. But with ASCollectionView, you're telling it to deallocate a whole bunch of nodes, reallocate them, reconfigure them, and remeasure them all. So that is something to be aware of. Any other questions? Any questions? I'm sure there's a billion probably about wait until updates are committed, but there's a dedicated Q&A section at the end, so you can.
So on the diagram, when it was like on the main thread at the top and then it returns back at the bottom, that whole area would be now, when you call wait until all updates are committed, that is now all blocked.
Precisely. That's very precise. That's exactly what's happening. Is in this diagram we have a chunk of main thread work at the beginning to get all the node blocks. Then we have a chunk of parallel concurrent background thread work. Then we have another chunk of main thread work where the finished nodes are inserted. If you call wait until updates are committed, wherever you are in the middle of this diagram, from that point down to the bottom is going to be blocked. So you're not going to do any extra work, but unless you're at the very end unless you're very lucky, you may do some extra work. Now it's important to note that wait until updates are committed is pretty inexpensive if there are no updates. So it's not like you have to find out whether there are any updates pending or not. Okay, cool.
Do you have any like recommendations on when to use that? Like,
my recommendations are use it if the design, if you or the designer, whoever has more authority, has decided that you're not allowed to render another frame until this update is done. So you've done some update, you like reloaded a section, let's say, I don't know if this is how it works, but like the pills at the top of the search results, you reloaded them and the designer says, I don't want to see, I just want it to flash immediately to the new set of data. Wait until submitting the update, the reload section update, and then calling wait until updates are committed will get you that. And then the other case is, if you're interested in the node at a particular index path after a certain update, then it's useful to wait. Okay, so I wish I had more time to talk about batch updates because I love batch updates. I'm a big batch update guy, but it's a big topic. So I'll just do a little bit. One of the fundamental misconceptions about batch updates is that they are updates. Really, perform batch updates performs one update, and the update is just communicated in terms of other updates. But it is not the same to perform updates X, Y, and Z versus performing updates X, Y, and Z in a batch. It means something else, and I've got a diagram to show you how it means something else, but it is one update expressed in those terms. And it's important, it's also, Uicollectionview rather, updates are very expensive. Uicollectionview allocates a whole bunch of animation objects and does a whole bunch of internal work. It's one of the most expensive things that we do is submitting updates to Uicollectionview. And so batching your updates, even if you could express the update as 2 updates or as 1, it's still much more efficient to express it as 1 update. And finally, this is a really important note that gets everybody, all data source updates since the last data source update have to be expressed in the update you submit to the collection view. If you express part of the data source updates that have happened, you're probably going to see a validation exception. And so I'm going to go into more detail on this, but at the outset, are there any questions about that? What's up?
So you mentioned
testing. So you mentioned that UIKit does internal consistency checks and stuff on each update. Does the batching, if you make big updates, then you say wait on all updates, does the chunking actually work against us? Because we do N. No?
It's okay. We got that. You will not get, you should not. Well, I have never seen Uicollectionview throw an update validation exception because ASCollectionView, our data controller and our ASCollectionView act as the data source, and it's architected in a way that it will provide valid updates to the collection view, and they will align with the number of items in section and number of sections.
In terms of accuracy, but in terms of performance, like.
It is true. That's true. But
okay.
The current thinking is that that's a really good question. Anybody else? Okay, so let's look at some quick sequence diagrams. I just love these things about batch updates. So I am missing a page, so give me a second.
just wanted to add something quickly about reload data. The best way to think about it with ASCollectionView is that it's an asynchronous operation. So, and it will, nice. Hello. So with reload data, basically you are triggering the start of a new update pass. And so that's why, you know, the wait until all updates are completed. Basically, the pair of those two things is similar to a Uicollectionview update.
Okay, so this is what I meant when I said that. Is my mic still going? I guess so. This is what I meant when I said that a batch update is one update, and that means that it is not the same to submit the same update, the same set of updates inside or outside of a batch. So for example, well, this is the next point. That point about them being different is, consider the example of you have 20 items and you want to delete item 0, 1, and 2. If you submit a batch update, then you're going to get exactly what you expect, which is the first 3 items are removed, and now you have 17 items. If you submit those outside of a batch update, then you're going to delete item 0, the items are going to shift down. You're going to delete item 1, which is actually like item C, if you want to think of it that way. It was what was originally item 2, and then all those are going to shift down. You're going to delete item 2, which was originally item 4, and all the rest of them are going to shift down. And so hopefully that's an example, like that explains what I mean when I say that you're expressing one single update in terms of a bunch of other updates. And one really important sort of side note about that is that delete section, insert section is not the same as reload section if you're inside of a batch update, because when you call reload section, the collection view is going to look at the old index from the beginning of the update and take into account any other updates that were submitted during the batch and figure out the resulting end index. But if you just delete from the index and insert at the same index, if you're inside of a batch, then any items inserted or deleted above that item will shift the index that the item moved to. And so you're going to swap the position of that item, and you may actually be inserting at an invalid index. So reload operations have to be decomposed internal to the collection view. You cannot decompose them yourself for that reason. Does that make sense? Okay, cool. So this is what I meant by the last note on the slide, which is all data source updates must be reflected in the collection view update. All right, I'm not going to go. All right, so let's take this example of a data source and a collection view. The data source starts with one section with 2 items, and the network reports that we have 3 more pins. And so now we have one section with 5 items. And in this case, we failed to batch, and so we submit 3 individual updates. So we submit insert item in index path 00. The collection view is going to call back to us for the number of items in section 0. We're going to return 5. The collection view is going to throw an exception because we had 1 item, we inserted 1 item, but now we have 5 items, and that doesn't make sense. Or we had 2, whatever. And we never get a chance to run these sequential updates, which would have caught us up. But like I said, the collection, all data source updates have to be reflected in one update. I think that makes sense, right?
For UIKit and for ASCII.
Yes. And so, you know, this, you could probably have intuited this, but this is what batching success looks like. We have 2, we get 3, we have 5. We insert them all together, and the collection view calls back to us. 2 plus 3 equals 5. The computer decides, and we're okay. So that is a couple of notes about batch updates, what they are, and why you should love them. Best practices, I've pretty much already covered these, but I really recommend that you center your logic around model objects. Not only is it safer in terms of things being deleted or inserted above you, but it's also a little bit more natural. You know, the user didn't select item 3, the user selected the brownies board, and that's what they want to see. I recommend implement node block for item index path and not node for item index path. And the reason is, if you implement node for item index path, then it will be in this first chunk of work right here, where all of the work that would have been shifted into the concurrent background thread will be done synchronously on the main thread. And so if you implement node for item index path instead of node block, you're getting much, much closer to the UICollectionView world, wherein you immediately take all the steps that you need to catch up to the data source, even if that causes hitching during scrolling or causes you to miss touches. So I recommend that heartily. And as I said, you can use never show placeholders if it's very important that your cells are never show their placeholder state. One important note about never show placeholders is that AS network image node and AS multiplex image node are configured to ignore never show placeholders because it's assumed that your app is designed to handle missing network images. Okay, so I don't have the stupid like questions slide, but questions? What's up?
So would it ever be advantageous to use node for item index path? But between that and just calling wait until all updates are committed in order to keep them in sync, which one's better?
Since node for item index path is closer to the UIKit model, is it ever better to use that if that's the kind of behavior you want? The answer is no. It's closer to the UIKit model in ways that this update will still be async because the node has been allocated.
No longer presenting.
Or maybe
I think the meeting. Yeah, sorry.
Okay, cool. So yeah, so the node has been allocated immediately, measured yet. So the measure will still, the measure or layout step will still occur asynchronously, and so you're still going to have an asynchronous update. It won't be done immediately.
So why don't you guys deprecate for item at index path?
I would. We might do it. We might do it at any time.
The main reason is that implementing a node block requires some work in the sense that you access the data source. You have to access it outside.
Yeah.
It's difficult to programmatically enforce that, so especially for existing clients. Have to enforce that we might.
Questions? Yeah, what's up?
Sorry, can I borrow the mic? Okay.
Yeah.
So you mentioned that background operations are just a normal priority and that never show placeholders will have the main thread wait on the background operation. And the main thread lends its priority to the background operation. Is it ever the case where like we would end up showing stuff on the glass earlier if we just globally turned on never show placeholders?
I suppose that's possible. It's pretty unlikely, but I guess it is possible if the kernel donates the priority and it gets a hold of a CPU before it would have. I think Tim's got a question.
Hello. 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 All right, cool. UIKit between UI table, UI collection view, like they have a lot of commonalities, but the delegates aren't exactly the same. The cells aren't exactly the same, but they're similar. And it seems like I'm not an ASDK expert, but it seems like that gap has been bridged. Like there's a cell class. Maybe the data controller is shared. So I was curious, like, is that the case? Is there anything interesting about building that, or?
Yeah, that's a good question. If he sounded garbled to the remote people, he was asking, you know, in UIKit land, Uicollectionview and UI table view are so completely separate, even though conceptually they're really similar. And was there anything interesting that came up in the implementation there, and how bridged is that gap? Yeah, we have bridged the gap. The data controller logic is shared. The cell nodes are obviously shared. So if you want to switch in your implementation, you can do that pretty immediately. I spoke to one of the engineers that worked on Uicollectionview at a party one time, and he was telling me that they absolutely wanted to re-implement UI table view in terms of Uicollectionview with a layout, a table view layout object, but there were binary compatibility problems and obviously a million things in overhead, so they didn't get to do it. So I'm glad that we were able to bridge that gap. One of the interesting things that has come up is UI table view was implemented in iOS 2, which predated blocks. And so the batch update mechanism for UI table view is to call begin updates, do your, submit your updates and call end updates. And the batch update mechanism for Uicollectionview is to call perform batch updates and perform all your updates inside there. And the latter is obviously a lot safer. It's a lot easier to ensure that your update calls are balanced. And it also has the interesting side effect of providing the update completion handler in advance of end updates. In Uicollectionview land, you provide the completion handler into perform batch updates. And so completion handlers in Uicollectionview are actually enqueued in sort of outer, inner, like sort of in order traversal in that way. Whereas if you use begin updates, end updates with completion, they'll naturally be called in, they'll be called in like inner 0, inner 1, inner 2, and then outer 0, outer 1, outer 2, because you've provided the block at the end of the update. So that was sort of interesting. And we are currently toying with the idea of, currently we provide both update mechanisms for both collections. And we're thinking about maybe removing the begin updates, end updates behavior from ASCollectionView because one, it's less safe and less easy to reason about, and two, because of that completion call order thing, we would like to mirror the same completion call order that Uicollectionview has. This is an awesome talk, Levi, man. I was just like, where's Levi? Okay, good.
Just one quick question. So when you get a call to start creating a bunch of these nodes and start creating measuring them in parallel, if the data actually changes and you get a new node or a new set of objects, like is there any kind of like canceling or kind of thing to like save
time?
Save time or continue work?
That's a good question. We have some basic support for that, which is if your data source, your view controller, your section controller, is deallocated or detached from the data controller, then we will cancel all the future work. And the next thing that we have plans to implement, cancel that. It will be tough to cancel. And you calling delete item at index path for like specific items to cancel that work. Basically, essentially, no, there's not great support for that, except for the deallocation case where you push to a new view controller, it started loading its data, and you immediately popped before it finished. We'll cancel the work in that case. That's a good question.
To the question about table and collection view, one interesting thing is that there is a lot of code duplication in table and collection view in ASDK, and although the data controller and range controller and the cell node are shared, one of the reasons that we've been trying to have everyone use collection node and table node instead is that it will allow us to have a shared superclass like AS range managed node or something, some abstract superclass that can then pull all the logic out of the collection and table views and have a shared superclass. So it's just that UI table view and UI collection view being the superclass, we can't do that now.
Anybody else? All right, awesome. Well, that was a blast.